Good afternoon. This is David Eastwood, Geotech Engineering and Testing. How are you doing? It's a beautiful day outside. Today, let's see if we can get this moving. Today, we're going to be talking about geoforensic engineering studying of a parking lot in Houston. This is an asphalt parking lot that we have in Houston near Hobby Airport. I hope everybody can hear. We got about 200 people RSVP'd, a lot of civil engineers, contractors, a lot of people from like agencies like county and the city, and some attorneys. So kind of interesting. My name is David Eastwood, Geotech Engineering and Testing. Of course, my email is de@geotecheng.com. My number is 713-699-4000. These presentations are going to be posted on YouTube channel. We have a Geotech Engineering and Testing YouTube channel that all these presentations are on there, and you can go out there and watch it, and then we will send you certificate for your CEUs for PDH hours. We're setting that up now. Geotech Engineering and Testing is located in Houston. It's been in business for about 35 years. We do geotechnical, environmental materials, and geoforensic engineering. We've got 60 people of engineers, geologists, technicians, support staff. We work all over Texas, Louisiana, New Mexico, and Oklahoma. And we have our own rigs, so we can mobilize your projects quickly. If you have questions, please type it in the QA section, and I answer them as I go through the presentation. Here's the site. Back in the old days in 2015, when we went out there, part of it was wooded. The part of the parking lot had trees on it was grass on it, but part of it was wooded like that. Now, if you go look at it right now, you got the Fast Park parking lot on it, and it's a beautiful place. And but the asphalt paving starts having problems. They had to go back and put a bunch of patches on there. A lot of bird bath, low areas. And you can see a lot of the areas got the bird patches on it. Let's see if you can. Yeah, so you see more pictures of it with patches everywhere. The asphalt starts coming apart just because of the problem with the subgrade and base material. So we had some areas near the entrance of the project was coming apart. You can see all the cracks here. These are brand new parking lot, you know. The project is near Hobby Airport. Highly expansive soils. You know how Hobby Airport soils are over there. They're pretty expansive. That's what it looks like. People can park over here. And this is a detention pond back in here. Here's the road here, and another road in here. We did the initial soil testing for the project in 2015, in May of 2015. So if you look at the project timeline, in May of 2015, we did the initial soil test. January, construction started. September, asphalt starts falling apart in the interior area. September, asphalt thickness irregularities were observed during the construction of the carport columns. October 3rd, record operations was done. See what the thickness of the asphalt is. October 26th, initial operations of the parking lot started. And then in October, November 2016, construction was completed. November 2016, the whole thing was opened up. In January of 2017, they were telling me that things are falling apart for me to go out there and look at it. We went out there, did 13 corings and 3 borings. And then in January 20, we did 3 additional cores. Then they hired somebody else to do 37 more cores throughout the parking lot. So we went out there, we had a truck rig out there. on the project, did borings. These are all clay. All the borings we did initially on the project, it's all gumbo clay. And if you look at the soils, they're high PI soils. You got a gumbo fat clay, PI of 49, PI of 40. Essentially, we had 0 to 20 feet when we did the borings out there, was all fat clay. That's really gumbo clay that experiences a lot of shrink swell problems. And you got PIs ranging from 31 to 64. So that was highly expensive. So design was a typical design for a parking lot like that. You know, 3 inches of hot mix asphalt, 3 inches of that, TXDOT top 40. Then we put 8 inches of crushed limestone, compacted to 100% maximum modified PROCTOR, not standard. When you do crushed limestone base, you have to compact it to modified PROCTOR. The subgrade, we told them lime stabilized about 8% lime by dry weight. Follow TXDOT 260 and 263. And that results in 48 pounds of lime for every square yard. And as you find out, they didn't put enough lime in there. They didn't compact the base correctly. So I'm going to get into that. Asphalt type, the type of the asphalt we were going to using was type D, which 100%, 98 to 100% of it passes ½ an inch sieve. And these are the gradation for it. 2 to 7% passes 200 sieve. Traffic loading out there was these buses. Were for fast parking. Of course, there were a lot of cars there. If you look at the aerial photos of the site, part of the site was wooded, part of it was grassland. You see the wooded areas. This is 2002. 2010, the wooded areas. 2014. 2016, they start construction. And of course, 2017, everything was in place. One of the things we checked when we did a soil test over there, we calculated the potential vertical rise, the PVR. Potential vertical rise is expressed in inches, is the ability of a soil material to swell at a given density at a specific location. So on this project, the areas that are wooded, they had a PVR of 2.8 inches. The areas that there was no trees, it was 1.65 inches. If you have trees and you have to cut them, the PVR is higher because trees suck so much moisture. The soil is so much drier that causes it to heave more. That's why the PVR in the wooded areas is 2.8 and in non-tree areas 1.65. If you look at the rainfall in 2015, before construction, we had 77 inches of rain that year. That's a lot of rain, 2015. And in 2016, they started construction in or about January, February of 2016. You know, we had 1.6, 4.4, 8.9 in April. May, we had 7.5. June, we had 8 inches. July, 5 inches. Total of 56.82 inches of rain that year, which is an average rainfall for Houston. But some of these months, we had a lot of rain during the construction. Here's a rainfall pattern. The one, let's see. If you go back. Huh. Doesn't go back. Let's see if you can go back. Yeah, it doesn't go back. Let's see. Yeah, if you look at the rainfall patterns here, you can see this red line here, pink line, is the rainfall for 2016. So if you can see during the construction, we had a lot of rain out there during the May, June, April, then it came down. So that's kind of tells you there was a lot of rain during the construction of this thing. And if you plot the initial moisture content of the soil at the time when we did our initial soil testing in 2015, That was the moisture profile. And if you have the profile for a dry soil and a wet soil, you can see that the initial soil moisture was very dry. So the site was very dry, so it had high potential for potential vertical rise for heave. And we got all these expansive soils that experience movement. You know, about these are the soils that in the US, they can expand up to 1,500%. This is by US Corps of Engineers. And if you do parking lots on expansive soils, you know, if you don't take care of the pavement properly, you can have lots of heave, and that's kind of the shape the pavement can be. The project specifications call for 3 inches of asphalt surface course, type D, 8 inches of base course, and below that, lime stabilized subgrade. Okay. Field exploration. So we did the pavement corings were conducted by others initially. They did some cores out there in 2016, 2017. We went out there. GET did a bunch of cores, and then again in March they went out there and hired somebody else to do a bunch of cores. When the initial guys went out to do the cores, they had cores about 3 inches, 3.2.25, 2.75, 3.25. That's the cores that they got the thicknesses. And these were the core locations on the project site. Then when the Geotech went out there and we did cores, we measured 4 inch, 3.5, 3.5, 2.5, 1.5 inch, 2.5, 3 inch, 3 inch, 2 inch, 2.5 inch. And the base was supposed to be 8 inches. We measured 5 inch, 5.5, 6.25, 7.5, 8.5, 7.5, 8, 8, 8, 7.5, 8. Lime stabilization, we found lime stabilization in some locations, but a lot of locations we couldn't find any lime stabilization. These green areas is where we do our borings and testing. We did coring first. We'll measure the core thickness. It's supposed to be 3 inches, and of course, in this case, it's 1.75 inches core asphalt. We start measuring the pavements, measure the base. That was the base material, crushed limestone. We did borings below that, check for lime. We put phenolphthalein on the soil sample underneath the base to see where lime was there. If there was lime there, it would turn purple like this. If there was no lime, there wouldn't be any color. Then they hired somebody else to do some coring, and these guys went out there and cored, and they got 3 inch, 3.75, 2.75, 2.5, 2.87, 2.1, pretty close to what we got. You know, there were some areas that were 3 inches, but a lot of the areas were like 1.8 inches, 2.1 inches. These are the core locations by the third party went out there, did some cores. Again, to measure the asphalt thickness about 2 inches, it's supposed to be 3 inches. The base, the same. The locations of all the cores by all 3 consultants, they are plotted here, and you can see there was a lot of cores on this project. So the pavement design called for hot mix asphalt concrete, asphaltic concrete type D, textile item 340, crushed limestone type A grade 1, lime stabilized subgrade 8%. When you do type D compaction of the asphalt, you got to compact it at lifts 1.5 to 3 inches. Nothing less than 1.5 inches, but nothing more than 3 inches. Base course was crushed limestone, 8 inches thick, compacted to 100% modified PROCTOR. At moisture content between optimum and plus 3%. So here's the base course, should have been compacted to 100% modified PROCTOR. This is the density test results on the base course from the testing lab. It shows ASTM D698. That's the standard PROCTOR, not modified PROCTOR. So they didn't compact that base per specifications of modified compaction. They compact to 100% of standard PROCTOR. So they use it like a steel drum roller to compact the base. You know, the way you check compaction, of course, you pick up a PROCTOR sample of the soils on the job site. You dry it up, chop it to pieces, add water to it, at different moisture contents. You compact it using 5.5 pound hammer, drop it 12 inches in a 4-inch mold, 5.5 inches, 12-inch drop, 25 blows per lift. You put 3 lifts and you compact it in the machine. This is the mold. You extrude it, you weigh it. You know the weight, you know the volume of it, dimensions of it. You can develop moisture density at different moisture content for that soil. It's called PROCTOR test. This is dry density, this is moisture content. At 7%, the density is 105. The optimal moisture, 11%, 122. And at 15%, the density was 110. So if your soil is wet, your densities are low. If your soil is dry, your densities is high. We wanted to compact that soil to 95% standard PROCTOR density. So that would be roughly about 120, 115 pounds per cubic foot. And moisture contents with optimum plus 3%. You want to compact the expansive soil on the wet side so that it doesn't swell as much. The wetter your expansive soil is, the less swell potential it has. So this is a standard PROCTOR. This is modified PROCTOR. This is density and this is moisture content. As you can see, the level of effort for standard PROCTOR is lower than modified. Modified gives you a higher density at the lower moisture. So if you compare the degree of compaction, standard PROCTOR versus modified PROCTOR, we find out that is a 5.5 pound hammer drop 1 foot. So the energy is 5.5 foot-pound. Here, the energy is 15 foot-pound. So it's 63% less when you do standard compaction versus modified PROCTOR. So they didn't compact the base properly. They didn't put enough energy in it. The subgrade lime stabilization, it was a type B lime, cured for 24/7 in 2 hours. Gradation, 85% past 1.75 inches, 60% past 0.75 inches. You scrape the ground, you apply the lime, you let it sit 24 to 72 hours, add water if you need to, let it to hydrate, break down the soil. That's what it looks like. Then you go pulverize it, mix it all up to small pieces. Initially, that's what your soil looks like. After you pulverize it with lime, that's what it looks like. When you do lime stabilization, you need to get a pH of 12.4. Otherwise, you're going to lose your lime stabilization. You got to add enough lime in there to get a pH 12.4. If you're less than that, lime will dissipate with time. Gradation, make sure that after you lime stabilize, the material passes the sieves. You compact with a sheep's foot roller. You seal it with a pneumatic roller. That's a sheep's foot, and this is a pneumatic roller. That's a compacted lime stabilized subgrade. You run density, make sure you got proper density on it. You can check with phenolphthalein and do depth check to see if there's lime in there. If there's lime in there, it turns purple. Now remember, if you stabilize 8 inches, the depth of this purple should be only 8 inches. If it's 12 inches, they're diluting the lime. You're not going to have a pH of 12.4. So your lime stabilization is worthless. Okay, it's not lime stabilization, it's modification, which time will lose that lime. So you measure the depth of the lime stabilized subgrade by phenolphthalein. We specified 8 inches of stabilization of the lime, and that's 8% lime per textile item 260, compact to 95% of standard PROCTOR density. The test report by the testing lab shows they brought in approximately 30.7 tons of lime on 14,400 square feet of the area. And for 6 inches, that was roughly 20.23 times the lime. So we calculated for a soil density of 9.37, area of 14,400 square feet, the amount of lime for 8% is almost 899,000 pounds. 8% of lime, 899,000 pounds is like roughly 36 tons. Okay, but the contractor only delivered to the job site 20.3 tons. So they didn't put enough lime in that subgrade. Various requirements by asphalt for agencies on asphalt construction, paving deficiencies. The thickness is very important. If the thickness was 3 inches and they have only 2 inches, that's not enough. City of Houston says if your thickness is deficient by 10%, you got to remove the parking. City of Galveston says remove the asphaltic concrete pavement if the deficiency is more than 10%. With respect to the base material that they put on the site, crushed limestone, and if you look at the Harris County document, it says the base will not vary in thickness. And if you look at this thing here, it says under thickness no more than 1 inch is under thickness, over thickness no more than 1.5 inches. So if your base material less than 8 inches by really is less than 7 inches, then it's not acceptable by the Harris County specs. Various requirements for asphalt compaction. These guys went out there and got a small rollers to compact the asphalt. You got to they use what's called a 6-ton roller. Well, City of Houston says you need a minimum of 8 tons rollers to compact that soil, that asphalt. And City of Galveston says use 8 to 10 tons rollers. If you look at the Harris County, it says vibratory rollers should have vibratory drums weighing not less than 8 tons. So these guys use 6 tons. So they need to compact the asphalt properly. Various agencies' requirements for base compaction. Basically, when you say compaction for textile, it says the base should be at least 100% maximum dry density determined by textile 113E, which is modified PROCTOR. Okay, which we recommended. The spec called for modified PROCTOR, but they compacted that soil by standard PROCTOR. And laboratory compaction characteristics, again, this is textile 113 that says 6-inch mold by 8 inches tall, and dry as 15 foot-pound, so which is a modified PROCTOR. Again, this is a standard PROCTOR for the base. It's modified PROCTOR, and you can see the degree of compaction. The density is much higher when you compact that base material in modified compaction, as opposed to standard PROCTOR, which the density is going to be much less. It's not as hard. It's not as stiff. Causation for pavement distress. 1, deficient in pavement thickness. Okay, when we measure the thickness of the asphalt and the base, based on the finding by GET and others, the thickness of the project asphalt ranged from 1.5 to 4 inches. Deficiency of the asphalt thickness was 0.152 inches to 1.5 inches. It's more than 10%. The base course pavement ranged from 3.75 to 8.5 inches. The spec called for 8 inches. So according to Harris County, it's deficient for more than 1 inch, so it doesn't meet the standard specification by Harris County. Deficiency for lime stabilization. When they added a lime, we suggested 8% lime. The spec called for 8% lime, but dry weight 48 pounds per square yard. They use 6% lime, and they use that 6% lime between 8 to 12 inches, which means that the diluted lime, so that lime is not going to be effective because they didn't have 8 inches everywhere. Inadequate compaction effort on asphalted concrete. Like we talked about, they have to use a big steel drum roller. They use 6 ton. They should have used somewhere between 8 to 10 tons. Compactor rollers to compact the soil, the asphalt. Inadequate compaction effort on the base course. This base course should be compacted to modified PROCTOR. They compacted to standard PROCTOR, which resulted in much lower densities and higher moisture. They should have used modified PROCTOR. That's a standard PROCTOR. It's a modified PROCTOR. So recommendations. So we were not going to go tear up that pavement. We had thicknesses that were deficient for base, for subgrade. The lime stabilization was not done right. So we went out there just to save money. We put overlay on top of it. We put type D overlay. Basically, we put a tack coat on it over the existing paving. It's a CSS-1H, CH1H tack coat. And you apply it, and then you put in type D paving on top of it. Again, we used the ASHTO pavement design using structural numbers. You know, the asphalt surface course has got a structural number, base course has got a structural number, lime stabilization has got a structural number. Based on that, we calculated design structural number of 2.44 for 20 years of life expectancy. And actually, the way it's designed right now, current design life, actual constructed life is only 15 years. So the construction life is only 15 years. This is the ASHTO nomograph that you go in there and you look at reliability, standard deviation, traffic loading, and then from that you get a structural number. So in this case, we were going to use type D for overlay. Minimum 1.5 inches overlay and 3 inches maximum for compaction. And we divide the parking lot into 3 areas. Okay. The area in dark blue, you need 2 inches overlay to get your structural number. The yellow, you need 2.25 inches to get your structural number. This area blue, you need 1.5 inch asphalt. Do you get your structural number of 2.44? So they went in there and they applied the tack coat and start putting paving in there, new asphalt on top of the existing asphalt. Compacted it, dug out the area that failed. All those areas were lime stabilized. Actually, they had lime stabilized it kind of like on the side, and they put it back in. We dug it out, lime stabilized it, and put it back in. Put in crushed limestone base. Compact it. Put tack coat. Run density, make sure everything was properly compacted. And then put in new asphalt in there. Compacted with the roller. Check the density. So that was the kind of the whole project. And of course, the contractor had to cough up a bunch of money to the owner on this case and to go out there and fix it. So if you got some pictures of projects that are interesting, please send them to me. I like to have pictures of failures on projects. This presentation is going to be on YouTube channel and Geotech Engineering and Testing YouTube channel. Program evaluation. I want you guys kind of look at this thing here and see what you think of the presentation. Let's see if you can launch a poll in here. See what you think of it. If you need to reach me, my name is David Eastwood, Geotech Engineering and Testing, and this is my email, de@geotecheng.com. My phone number is 713-699-4000. These are all the programs that are coming up that we're going to have webinars on. And like January 12th, we had the hobby airport thing. Next 2 weeks, we're gonna have land development. January 26th, storage dome collapse. If you email me your contact information, we put you on the database. You get notices of these free webinars. You're gonna get your PDH hour on this thing, within the next couple of days. Any questions? Any questions on this topic? Well, I guess it was pretty clear. Well, I appreciate your time. And we're looking forward to see you in 2 weeks for another presentation. Make sure you send me your contact information so that I can, so that we can get you notice of these presentations. Thank you.